Hello and welcome to yet another video of Cornerstones of Math. In this video, we are going to calculate these 6 integrals. These are integrals of some of the simplest rational functions. More specifically, they all belong to the form integral of x to the power of m divided by ax plus b to the power of n. So let us gain some useful tips on integration of these types of functions while trying to solve these integrals. Before we dive into actual problems, let us start by reminding some of the most basic integrals that can be useful here. The first one is the integral of the reciprocal of linear function ax plus b, which can be considered the most basic function that gives logarithmic function when integrated. The antiderivative is 1 over a times ln absolute value of ax plus b plus constant c. The second one is basically all the other cases for ax plus b raised to the nth power. That is, n is not equal to -1. This is often called the power rule of integration, where the antiderivative is ax plus b to the power of n plus 1 divided by a times n plus 1 plus c. For other complicated integrals given in the problems, we basically split and convert the given integrand function into these two basic functions. So now let's actually get started. As for the first problem, we have integral of x over 7x plus 8. Notice that the numerator is of the same degree as the denominator. Therefore, we split the integrand into constant plus constant divided by 7x plus 8 form, which are two functions that can be easily integrated. We can do so by writing the numerator as 1/7 times 7x plus 8. Then, in order to remove the constant term, we subtract that term, which is 8 over 7. So for the first part, we have the constant function 1/7, and for the second part, we have 8 over 7 times 1 over 7x plus 8. If we integrate, the first part gives x over 7, and the second part gives 8 over 7 times 1 over 7 times ln absolute value of 7x plus 8 plus constant c. So we obtain x over 7 minus 8 over 49 ln absolute value of 7x plus 8 plus c. Next, the second problem, which is the integral of x over 5x minus 6 squared. The process is quite similar to the previous problem. We don't want x here, we want 5x minus 6 here, because then it can be cancelled out. So we make 5x minus 6 in the numerator by writing 1 over 5 times 5x minus 6, then plus 6 over 5 to remove the constant term. Then we have 1 over 5 times 1 over 5x minus 6, plus 6 over 5 times 1 over 5x minus 6 squared, where both terms are now easily integrable. Therefore, we can write the given integral as 1 over 5 times integral 1 over 5x minus 6 dx plus 6 over 5 times integral 1 over 5x minus 6 squared dx. And as for the first term, we have 1 over 5 times additional 1 over 5 coming from 5x plus 6, then ln absolute 5x minus 6. And as for the second term, we have 6 over 5 times 1 over 5 from the coefficient of x, and -1 from the power -2. And then we have 5x minus 6 to the negative first power, hence 5x minus 6 here. So we have 1 over 25 ln absolute 5x minus 6 minus 6 over 25 times 5x minus 6 plus c. As for the third and fourth problems, we have x squared at the numerator. Notice that now the numerator is of higher degree compared to the denominator. In this case, we divide the numerator by the denominator to obtain the quotient and the remainder. In other words, we rewrite the numerator in descending order of the denominator 3x minus 4. You may write x squared as a times 3x minus 4 squared plus b times 3x minus 4 plus c and compare coefficients to determine the values of a, b, and c. Or in a much quicker way, you can do this. We have x squared, which means that we surely have 3x minus 4 squared term when rearranged in descending order of 3x minus 4. In order to have coefficient 1 in front of x squared, this quadratic term must be multiplied by 1 over 9. But then we have undesired linear and constant terms on the right-hand side. More specifically, this part is 1 over 9 times 9x squared minus 24x plus 16. So in order to remove linear and constant terms, we must add plus 8 over 3x minus 16 over 9. So now we have 8 over 3x term, and you can easily rearrange this into 3x minus 4 term by writing 3x minus 4, and now this must be multiplied by 8 over 9 to give 8 over 3, and since this gives constant term negative 32 over 9, we add 32 over 9, and then this constant term minus 16 over 9. So we have 1 over 9 3x minus 4 squared plus 8 over 9 3x minus 4 plus 16 over 9. Therefore, if we divide this by 3x minus 4, then our integrand function can be written as 1 over 9 3x minus 4 plus 8 over 9 plus 16 over 9 times 1 over 3x minus 4. And now we can integrate each term easily. So now we have 1 over 9 times integral 3x minus 4 dx plus 8 over 9 times just integral dx, which means integral of 1, plus 16 over 9 times integral 1 over 3x minus 4 dx. So we have 1 over 9 times reciprocal coefficient 1 over 3 times reciprocal power 1 over 2 times 3x minus 4 squared plus 8 over 9x plus 16 over 9 times reciprocal coefficient 1 over 3 times ln absolute 3x minus 4 plus c. So it is 1 over 54 3x minus 4 squared plus 8 over 9x plus 16 over 27 ln absolute value of 3x minus 4 plus c. Or if you expand the first term, we have 9x squared minus 24x plus 16. So we have 1 over 6x squared, then this term plus this term, which gives minus 4 over 9x, and this constant term, which is 8 over 27. So this plus 16 over 27 ln absolute 3x minus 4 plus c. Here, this constant term 8 over 27 can be combined with this constant c to give new constant of integration c1. So we can write 1 over 6x squared minus 4 over 9x plus logarithm term 16 over 27 ln absolute 3x minus 4, then plus constant c1. But we don't actually need this subscript 1 here, since the constant c in the indefinite integral generally refers to all constant values, so we can just write this plus c. For the next one, both numerator and denominator are of degree 2. We use the same process as in the previous problem. That is, we rearrange the numerator into descending order of 2x plus 1. Let's use the quick comparison method just like the previous problem. So first we write 2x plus 1 squared, and obviously this must be multiplied by 1 over 4 now. Then to remove linear and constant terms, we need to add minus x minus 1 over 4. Then as for this minus x, we write 2x plus 1 then multiply minus 1 over 2 here, which gives constant term minus 1 over 2, so we add 1 over 2 here. And the remaining constant term minus 1 over 4. So we have 1 over 4, 2x plus 1 squared minus 1 over 2, 2x plus 1 plus 1 over 4. And the integrand function can be obtained if we divide this by 2x plus 1 squared, which equals, now the first term becomes the constant term, 1 over 4, then minus 1 over 2 times 1 over 2x plus 1, plus 1 over 4 times 1 over 2x plus 1 squared. Now let's integrate each term. So we have 1 over 4 times integral of 1, minus 1 over 2 times integral of 1 over 2x plus 1, and plus 1 over 4 times integral of 1 over 2x plus 1 squared, which gives 1 over 4x minus 1 over 2 times 1 over 2 times ln absolute value of 2x plus 1 plus 1 over 4 times 1 over 2 from here, negative 1 from here, and negative first power of 2x plus 1 plus c. So we have 1 over 4x minus 1 over 4 times ln absolute value of 2x plus 1 minus 1 over 8 2x plus 1 plus c. Next, we have integral of 1 divided by x times 12x minus 11. And the thing is, you may have already seen how to deal with this expression quite a lot. Since there are two linear functions x and 12x minus 11 in the denominator, we use the partial fraction a over x plus b over 12x minus 11. Now some of you may already know the fancy trick to determine coefficients a and b, such as the cover-up method. But in this video, I am just gonna use the comparing coefficient method, which can be considered a basic method that are more familiar to many people. So if we reduce to the common denominator x times 12x minus 11, we have a times 12x minus 11 plus b times x. So we have 12a plus b times x minus 11a. Comparing coefficients, we obtain 12a plus b equals 0 and minus 11a equals 1. This is quite an easy system of linear equations which you can easily solve. Then we obtain a equals negative 1 over 11 and b equals 12 over 11. That is, in our partial fraction expression, we have negative 1 over 11 here and 12 over 11 here. Therefore, the given integral can be written as minus 1 over 11 times integral of 1 over x plus 12 over 11 times integral of 1 over 12x minus 11. So we have minus 1 over 11 ln absolute value of x, and then 12 over 11 times 1 over 12 times ln absolute value of 12x minus 11 plus c. Notice that both first and second terms have coefficients 1 over 11. Therefore, we can write 1 over 11 times the second term ln absolute 12x minus 11 minus the first term ln absolute value of x. Combining these two logarithms, we can write our answer as 1 over 11 times ln absolute value of 12x minus 11 divided by x plus c. And now the final one, the integral of 1 over x squared 9x plus 10. Here we use the partial fraction method again. But since now we have squared term for x, we need two terms for x. A over x squared, then b over x, then the other term c over 9x plus 10. Now some of you might ask, what about 1 over x times 9x plus 10 term? If we require quadratic term in a partial fraction expression, shouldn't we also include this term? Well, this term can be further split into partial fraction p over x plus q over 9x plus 10, which are already present here. So we only need to consider 1 over x squared, 1 over x, and 1 over 9x plus 10 terms. Reducing to the common denominator, we have a multiplied by 9x plus 10 plus b multiplied by x times 9x plus 10 plus c multiplied by x squared, which can be rearranged into 9b plus c x squared plus 9a plus 10bx plus 10a. Therefore, comparing the coefficients, we obtain 9b plus c equals 0, 9a plus 10b equals 0, and 10a equals 1. So solving these equations, we obtain a equals 1 over 10, b equals negative 9 over 100, and c equals 81 over 100. Therefore, we have 1 over 10 here, negative 9 over 100 here, and 81 over 100 here. Therefore, the integral is now converted into 1 over 10 times integral of x squared minus 9 over 100 integral of x plus 81 over 100 times integral of 1 over 9x plus 10. So we obtain minus 1 divided by 10x minus 9 over 100 ln absolute value of x plus 81 over 100 times 1 over 9 times ln 9x plus 10. Here both logarithms have constant 9 over 100 at the front, so we can combine these two logarithms and write minus 1 over 10x, then 9 over 100 times ln absolute value of 9x plus 10 divided by x plus c. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.